மாணவர்களின் சிந்தனைகளை வடிவமைக்க institutions மாணவர்களின் தனித்திறமைகளை மேம்படுத்த SNS institutions மாணவர்களை போற்றும் SNS institutions கோவை.
Discussing about calibration of Ammeter and Wattmeter, and also we are discussing about some kind of errors and what are the errors that occur in this meter. So even though we are using a moving ion instrument, so moving ion instrument is used to measure the AC voltage or AC supply. Moving voltage we can use as a DC power source. Okay, so this one is for AC. So in AC side we are using a moving ion mechanism, and then moving ion meter. So this meter is going to be calibrated. So we don't know this meter is right or wrong. So we are going to calibrate this meter. So before that we need to find the errors. So how much amount of error is there in this meter we need to find out. So and also error we have a different kind of error. For example, manual error, random error, and also the measuring instrument error. So we have a different kind of error. So error is whatever it may be, there is no problem. But we are going to calibrate the meter. So when we are calibrating the meter, we need some kind of standard meters. So because based on the standard meter only, we can calibrate either the meter is reading this right or wrong. So now we are taking that standard meter is in this multimeter. Okay. So but in real time, the standard meter should be available in this national laboratories. So in that laboratories, we are giving the meters. That meter is going to be calibrated with the help of a standard meter in national laboratories. After calibrating, they will give some kind of certifications. That certification valid up to 1 year. So in that 1 year, the meter value will be correct. After 1 year, again we need to calibrate the meter, right? So in this experiment, we are going to check the error, how much amount of error is there, and then how much percentage of error is there. So this one will be the voltmeter. So first, calibrating the voltmeter, we need to know how we are going to connect the voltmeter. So the voltmeter is nothing but it is a voltage potential. The potential difference between two nodes, the nodes is nothing but base and then neutral, right? So we are going to connect the voltmeter in a parallel to the supply voltage, right? So when we are going to calibrate the ammeter, we can connect as a series combination. But in voltmeter, we will connect in a parallel combination, right? So I have in a supply voltage. So in the supply voltage directly connected one voltmeter. This voltmeter will be a standard one. That voltmeter will be a multimeter. And the next voltmeter, this voltmeter is a test meter or a measuring meter. So when we are switch on the supply, standard meter will show some value, and then test meter will show one value. So we have some different kind of value. So when we are directly connected to the supply, we can calculate only one reading, but we need a more than 5 reading. So that's why we are using a variac. So variac is nothing but variable auto transformer, right? So the supply voltage is 230. That 230 supply voltage is given to 0 volt to 270 volt. So 0 to 270, we are taking 5 to 10 reading. Each and every reading, how much amount of error is there. So based on that, we will say that this meter is error or errorless. When the meter is errorless, no need to calibrate the meter. When the meter will be error, we need to find either it will be a positive error or a negative error. So positive error means we need to tune the knob. So this knob is connected to spring of this meter, right? So the calibration is the next process. First we need to find the error of the meter. So first switch on the supply. Now the 0 volt, the testing meter will show 0 volt, and then test meter, and then standard meter. Both the meter is showing 0 volt. So next I am increasing the voltage potential. So I am connecting the resistive load. Why we are connecting the resistive load means when we are connecting the resistive load, that load will be give unity power factor. So that means the current and the voltage waveform will start at one single point. So now the test we have in a tabulation serial number, and then standard meter, test meter, and then error. So error is nothing but test minus standard, right? So first one, test meter is showing 65 volt, right? So next one, again I am increasing some amount of voltage. Standard meter will show 83, the test meter will show 85. Then again I am increasing the voltage value. The standard meter will show 102, and then test meter will show 104.
Sir, 100
So we are fixing that 101 or 102. So next one, I am increasing the voltage value. 126. This meter will source 10, 20, 30, 130. Again I am increasing. Standard meter will source 160 and then test meter will source 165. And final reading, we are taking standard meter 187, test meter will source 186, 186 something. 189. Right? So this will be the reading. So next we are going to calculate the error. So see, so the value will be the 62. Now the test meter is showing 65. So what will be the error? 65 minus 62. So that means 3 plus 3. So positive 3. So positive 3 means it will be leading the reading. Actual value will be the 62. But the test meter will source plus 3 reading. So that means we need to negative calibration. We need some kind of negative calibration because already it will be a positive error. So positive error means we need a negative calibration. Negative error means we need a positive calibration. So 85 and then 83 plus 2 and then again plus 2, here plus 4 and then plus 5 and then plus 2. So this will be the error. So what will happen when the calibration occurs? So when after calibration the standard value will be so 62 means the test meter also should show 62. So once the calibrations are completed, after that again they are taking the same kind of procedures. So each and every step the error should be in a 0. So when the error will be 0, the meter is calibrated. So this is the calibration procedure, right? So only one difference is voltmeter and the ammeter is when we are connecting the voltmeter should be connected in a parallel. Ammeter means the ammeter should be connected in a series combinations. This is the only one difference. Okay. So I hope you understood the concept of calibration of voltmeter, right? Okay, thank you.